I almost got hit by a car earlier. I know what you're about to ask. How did they get one of those fancy horns that changes the pitch? Well, I did my research, and it turns out you already have one. In the driver's perspective, the horn still sounded just like this. The real reason it sounded different is because of the Doppler effect. The movement in the car caused a change in the sound wave's frequencies between the horn and me. The textbook definition of the Doppler effect is the apparent change in frequency of a wave caused by the relative motion between the source of the wave and the observer. When the car was moving towards me, the sound waves it was emitting bunched up so that it was delivered at a higher frequency or pitch. Then, as the car passed me, the sound waves delivered at a lower frequency. It's kind of like an accordion. This doesn't only work on sound waves, it works on any kind of wave. For example, the police will flash a laser beam at your car, which reflects back to the cop car so it can analyze the shift in frequency of the laser light. They use these to calculate your velocity. They sure could have used a speed radar to calculate how fast the maniac was going before he almost hit me. You probably know that colors have different frequencies. Higher frequencies of light give off a bluish hue, whereas lower frequencies of light give off a reddish hue. If a star is moving towards you, then the light waves squeeze, appearing slightly bluish. However, if they move away from you, then they expand, appearing reddish. This is called redshift. You can't see this with the naked eye, but astronomers have their tools to measure this. They have found that galaxies exhibit a redshift, meaning they move away from us. Galaxies aren't actually speeding away from Earth. According to Einstein's theory, the redshift in the galaxies is caused by the expansion of the universe. Think of the universe like a balloon. When you blow it up, the points furthest away from the center are moving the fastest away from the center. Hubble found that this is the same with galaxies, and the speed and distance of galaxies is a constant, known as Hubble's constant, which is arguably the single most important constant in all of cosmology, and undeniable evidence of the birth of the universe. The Big Bang. We can run this videotape of an explosion backwards until all the debris collects to a single point. Since we can find the velocity at which the universe is expanding, we can roughly work it backwards to calculate the time when the Big Bang did occur, which astronomers have found to be 13.8 billion years ago, which is pretty crazy that the same Doppler's effect that can be used to explain the pitch changes of the car horn and the speed radars that police use can be also used to explain the movement of celestial objects and the beginning of time.